Hello guys, we are back with another Leetcode challenge. Let's see the today's challenge, and the challenge is binary search tree iterator. This question is fall into the category of medium and it's highly like. So it's the must do question. If you want to try to attempt a design algorithm type question, you must attempt this question. So let's deep dive into the question. What actually question ask? So you have a given and you have to implement the BST iterator class that represents an iterator over the in order traversal of the BST. So you have a given a three functions. First function is a constructor onset which is going to initialize an object of BST class iterator class, and the root of the BST is given as the part of the constructor. Okay, the pointer should be initialized to a non-existent number smaller than any element in the BST. So it's the constructors over there, and you have given a hash function which is going to return if the number exists in the traversal, otherwise it give us false in that case. And another function is int next function. It return next int value. What is actually if the point move the pointer to the right and then return the number of the pointer, what value is exist on that index on the pointer, so it's going to return that. So and notice that by initializing a pointer to a non-existent smaller number, the first call to the next will return the smallest element. Okay, it's pretty much straightforward. When we call the first time next, it's going to return a smaller value. Again, if we call the next function, it's going to return a little bit greater than that smaller number going to return. So it's like a in order, we are just traversing into the in order way, and you may assume next call will be always valid, so no need to thinking about the invalid cases. So it's always valid, and there will be at least a next number in the order traversal when next is called. Okay, in number is existed in that in order traversal whenever we call a next function. So it's pretty much straightforward. It's a BST, and we know the property of the BST, very important property. When we traverse in the in order fashion, or if we traverse in order and store in somewhere else in the vector and array, and when we iterate over the in order, and when we saw the vector or array, the vector array will be sorted in the increasing order. So that's the point we have to notice. We have to know about that. We always get a sorted increasing array or vector. So in that case it's pretty much straightforward. Let's deep dive into with the question, example one. So you have given this BST tree, and when we call next, I'm going to first and foremost what is going to return this 3, and when again I'm calling next, it's going to return a second smallest 7 is there. Has next, it's a true because it's not reaches to the end of the array. So that's pretty much straightforward, guys, I guess. Let me just write the code, then you understand what I'm trying to explain you. So first and foremost, what I'm going to do, I have to take all the root value into the vector into in order fashion. So first and foremost, I'm going to make a vector. Let's name it V, and after make it, what I'm going to do, I'll call it my in order, which is going to store the which going to traverse into the in order fashion and store all the nodes value into this V. And after that, I'll need a in pointer which is going to point to initial value, and we know if we want to run in the one time, so that's why I'll just write this thing into the constructor, because I know constructor is running only one time and we want only one time it's going to run. So that's why I'll just call my in order function into this constructor, and I pass position pose variable equal to 0 because I have to want to run this on the in the one time. So that's my one of the motto. And in order, what's going to in order function, what it's going to do, it's going to store all the value into this V in this order. So what's my actually duty only, just I have to return v of pose plus plus. Why I'm doing this? V is equal to 0, and after that whenever I call this function I have to move my pointer, so that's why I'll just in the one step I'll just pose plus plus. I'll do the two things in a one line. So that's pretty much about the next function. It's a little, it's a easy to implement, I guess. And what about the hash next? If v dot size means if my position is equal to v dot size, it means what is it indicate? My array size 5 and my position is also 5, but I started my position equal to 0. So what does this actually indicate? My position is greater than my v. What does this mean? It's actually out of one case in the v dot size, because I know the indexing in the array and vector will be started from the 0. So when both are equal, it means the position is out of bound by v. So in that case I'll return what? False. No need to go, sorry, it's a false. So let me write 0, and if not the case I'm going to return true. So that's my code, guys. But yeah, first complete the in order. So for completing in order, let's write it just stuff function. It's a void type because I don't want to return anything, and it's take one parameter. It's a root, and you know very well how to write in order. If root equal to null, in that case what I'm going to do, I'll just going to return it from here. For in order purpose, I have to move left side of the root, then push this element into the my vector root. Well, after pushing the value of this root, I have to move right side of the root. So let me write, just move to the right, and that's it, guys. That is my code. Okay, let's run this code, guys. Okay, we pose, wait, give me we pose plus plus, not, oh, I'm defining wrong place. I have to make sure it's a global. Run this code, and it's accepted. Let's submit this code and see what was the result. What is the result? Yeah, that's accepted. So if you have any doubt in the code, let me know in the comment section. I resolve your doubt as soon as possible. Until then, keep grinding, guys, and stay tuned.